In this episode of FUM0134 Machining, we are going to finalize the braking mechanism for this tailstock. It will be a different design than the original. I didn't like the original at all. I want to lock the base plate to the ways, not the entire thing. There is a reason for that. And now, let's cut the crap and some metal. The first thing before we start with the lathe work with this one is to make this surface finish inside this hole a little bit better using this one. This is a tool I made. Well, it's just a roll of emery paper and then some backup filling which makes it tight into the hole, and I will now drill it in a way. Okay, let's see what this does. I need to tighten it a little bit like this, then it probably goes into the hole. Yeah, it did. Then some oil. Okay, now it's high speed. Yeah. Wow. Yeah. Oh. 25mm cold rolled stock, and now I will dial it in here. Okay, now let's face this one. I'll bring you a little bit closer. Face. Like that. This tool. Let's first touch it. Now I will take 500ths of a millimeter cut. No more. Let's see if I can make a good finish there. Well, I think that did it. Okay, now I will peel off 25 hundredths of a millimeter from this, so nothing much. Yeah, let's see. And then, sorry, you are riding my tailstock, so. And now let's take another cut here and see if this works without chatter. I will now take 1/10 of a millimeter cut here. Let's see how this works. Let's see if we can use the feeding mechanism here. Well, let's see now. It's a little bit heavier cut now, and I don't want to use any cutting oil here, just raw. It's still a little bit musical. see where we are at the moment. So now it is 24.35, really? I made a mistake somewhere. Well, we can actually check this. You are riding the tailstock again. Like that. I want to have something to protect my waist when I try this out. Well, it's there. It's perfect. Well, and I don't know where I made this mistake. That's bad, actually, because I should know. And this is a very simple operation. It's just doing with compound. Okay. We make it 50 millimeters deep, and then we thread it. So let's go on with this one. And here you can see how this tailstock is. One millimeter more, and then some for the thread tip, for the drill tip. There you are. Okay. By the way, this was 8.5 millimeter hole. This chamfer should be quite large. Why is this? Larger. I think there you are. Looks like that. Okay. And now the tapping. This is tap holder, spring-loaded center. It's leaning into the center hole of this M10 tap in this end. And then we have a spiral flute tap here. So I probably don't need to cut the chips. And then we just make the threading. Well, let's see how this goes. Well, it goes. It's needs some torque here. I think we are there. Yeah, that's the bottom. And now I release this thing. Yeah. Well, we should have a nice M10 thread there. See there? And now becomes the funny part. We will try to part this off. And this is always fun. I start with very low RPM just to see how this does. Well, I could probably use a little bit more. There you go. Huh. Yeah. This is horrific. Okay. For this corner. Okay, let's go on with this thing. Clamped into the table, with one machinist jack here, then two clamp and two more two clamps, so that well, it's dialed in. And there is furthermore one thing that we need to do. It's this this thing we made in the lathe. It goes into that hole. Okay. But it shouldn't, because now what I want to do, I want to drill it like on the same drilling operation, so that the holes match. Yeah, that's the purpose of this thing. And how to hold it so that it doesn't drop through, well, I use this piece. And then we have this M10 thread there, which is very nice actually. There is one side that is really, this is not flat, this is flat. So, well, yeah, so I put it here, tighten it properly, and then I just put it there. And then I use this machinist vise to tighten it there. And that's it. Well, here is another view for the operation. So what we have here is a 14mm drill. This is a split point drill, which means that it doesn't wander. So I have there you might see or might not see, there is my center punch. Well, here is the other drill. It is 14.5 millimeters. and it cuts really nicely now when we have this pilot hole, so now no trouble there. Now I have marked here, it should be 105 millimeters deep, so let's go. Now there is a problem with this reamer. It doesn't evacuate the chips as I expected. It pushes them into the hole like a gun tap. And so I need to evacuate them manually every now and then. And now let's ream a little bit more. Put some oil into there too. In this we already have quite a lot. And let's evacuate the chips.
So we are so far 1, 2 and 3 parts done. So this is actually quite simple mechanism. You saw me in the lathe making this eccentric part, okay, and then I made a groove there. The overall diameter is exactly 15, no, it's 14.97 millimeters. And there is some deviation. And then I made a taper in this end, and there is this has the same taper. It's 1 to 8 taper, so it's not very, it doesn't grip very much, but when you tighten a screw it will hold quite well. So now how this goes together is that you first start this one from here, like this. Well, I have this bolt here just to make it easier to handle this, yeah. And as I estimated, okay, now it's the correct way because this goes there, like that. And there is, at some point we have like that. Okay. And then, of course, this could slide away from here, which is not desirable. You could easily slide it away. But I made here the groove is for this ball, goes into there. Then quite light spring, like that. And then one screw. This one is not the one that will be used. It will be a very short screw, which is then followed by a nut so that it's in place. It's just, and now it's really tight there, and there is no oil at the moment. So this is a little bit, I don't want to turn this a lot because it might start galling. And then you just put this here, like that. And of course we are going to have a handle here, maybe this material. It doesn't require a lot of force actually when in operation. And then I made a detent here, so it locks in free position. Now it's free. and when you turn this, it pulls down, actually locks it. And why do I have this detent there? The reason is that when it's really oiled, the handle might move by itself. Not when it's locked, but when it's unlocked. So this active detent holds it in place. Yeah, and it's really nice. Goes there like nothing. And now, this is the thing. All we need to do is to find out a good screw here and then the nut. This is the underside of the thing, so there is room for one screw and nut. This concludes this episode of Fabricating machining. We made quite a progress with this one. The locking mechanism includes some horrible drilling, and it's successful. There is no excessive play anywhere. Even the taper for the handle succeeded, and that was quite a miracle, because the compound of my lathe is crap. And in the next episode we will inspect that crappy compound and see if there is anything to do with that one. I believe there is, but that's in the next episode of Fabricating machining. Yeah. Till then, bye!